Hello everyone, good morning, good afternoon, and good evening, depending on where you are. This talk is focusing on an important issue, the awareness, education, and training of young developers on algorithmic fairness, accountability, transparency, and ethics, or FAccT. The work has been done in collaboration with my co-authors, Maria Kasinidou, Pinar Barlas, and Jana Otterbacher, and the Science Center of Excellence in Cyprus, previously known as RISE, with which Jana, myself, and Pinar are affiliated within the Transparency in Algorithms group. Algorithmic decision-making is widely used for contributing to decisions affecting people's lives. Job hiring, healthcare, education, finance, and criminal justice are just a few of the examples where algorithms are taking on what previously were human decision-making tasks. While the use of algorithmic decision-making has prospects to make decisions more efficient and reliable, as we have seen from previous work, concerns have been raised about the fairness and justice of such decisions. These systems do not always behave as they should, making decisions that may discriminate against certain groups of people. There are many examples in the press, and we have seen several other examples in the academic literature. So we agree that fairness is in itself complex. There is a lot of work on fairness and justice constructs in the psychology literature, and here you can find a comprehensive review in the reference that is provided in the slides. With regards to algorithmic fairness now in decision-making, recent work in HCI and FAccT has looked into perceived fairness only to find that people understand fairness differently and according to the context where the system is operating in. As users are becoming more aware of the concept of algorithmic fairness, they are starting to worry about potential biases in the decision as well as in the data or in the algorithm interaction. They seek more information about how different factors weighted in the decision and whether an algorithm uses sensitive attributes such as race or gender. Variables such as the computer literacy and favorable outcome, as well as development procedures of the system, have been proven to correlate with the perception of algorithmic fairness. In particular, people rate the algorithm as more fair when the decision is in their favor, irrespective of whether it appears to be biased towards certain social groups. Emma Pearson showed that there are gender differences in perceptions of algorithmic fairness, while demographic differences contribute to the variability of opinions on fairness. Looking at the recent work on perceptions of FAccT, and if referring back to the literature, we can find a great amount of work on how the users perceive elements of FAccT. However, we think that is equally, if not more important, to understand how the people behind the development of those models and algorithms perceive those concepts through the systems they are developing. Before going into that, let's talk a bit about explanations, which appear to be the most popular method for transparency. With machine learning models being exploited for predicting sensitive individual information, classifying individuals in categories, and providing decisions that were previously taken by humans, there is a need for interpreting those models in a way that the user would understand. What is important here is that the user should be able to understand the potential consequences of applying the decision provided by the system in the real world. Hence, explanations should be informative and easy to be interpreted by the person they are created for. Edwards and Viale argue that pedagogical approaches to explanation, that is, explanations that teach how the model works, might be more promising for the general public than the compositional approaches, that is, breaking the model down with the risk of trading secrets and intellectual property breach, which might be more suitable for experts. Studies with users, however, are inconclusive as to what type and level of explanation the users prefer. And looking into Holstein and co-authors' work, which is providing us with some important insights on how developers are struggling to find a balance between fairness in systems and providing a product for their companies. They are calling for procedures, processes, and training on concepts related to FACT for developers who are already in the business. Thus, it is important for us to understand how future developers deal with certain explanations provided in the scenarios they were given. Furthermore, we looked into how different decisions change their perceptions of fairness and whether the context and the output also have an impact on their perceptions. And this is the focus of this work. And in order to do that, we ran a survey between September 2019 and May 2020 with undergraduate and postgraduate students in disciplines adjacent to algorithmic development. Participation in this study was voluntary, and all participants provided us with written informed consent for their data to be used for research purposes. We recruited 99 undergraduate and postgraduate students. Most of the participants identified themselves as postgraduate students, and most of them were master's students. The rest of the participants were self-identified as undergraduates, with their majority being in their third or fourth year of study. You can see here in the table the degree they were enrolled in. The majority of the participants were studying at institutions in Europe and the UK, and the rest were in the USA, Israel, China, Brazil, and Australia. Participants in this study were presented with three scenarios where algorithms made decisions that influenced humans. We selected contexts that our target population is familiar with. Two of the three scenarios were used to trigger the participants' judgment on the use of particular factors, for example, demographics, that were considered for decision-making and explanations. In the third scenario that we will see in a bit, three different decisions were presented with the purpose of examining whether participants' perception changes according to different outcomes. To examine the overall perception of the young developers, we used the following constructs extracted from the literature that are related to fairness and justice. The participants needed to indicate their agreement to the following statements using a 5-point Likert scale. Now let's talk about the results. We were expecting that the people who indicated agreement with the system's decision would also believe that the person in the scenario deserved the outcome. Surprisingly, we found significant statistical differences in their opinions in both scenario 1 and 2. In both scenarios, there was a considerable number of participants who selected options 4 and 5 on the agreement scale, while also a large number selected options 1 and 2 on the deserved scale, indicating that they agreed with the decision, but the person in the scenario did not deserve the outcome. Looking into the qualitative results in scenario 1, when the participants asked to elaborate, they focused on important factors about the situation that were not taken into consideration. This included, for example, the context. So, context of the day of the accident, the time, the weather, the road infrastructures. Interestingly, some participants even mentioned the need to consider other factors, even when they indicated they found the information provided as sufficient. They referred to the similar cases on which the prompt said the decision was based, although the prompt explicitly stated twice that the decision was based on thousands of similar cases from the past. Participants often remarked that a single example is not enough to adequately explain decisions. They also mentioned the decision-making process. Most participants wanted to know how much each factor contributed to the decision, some specifically asking for additional explanation on how age, driving at night, etc. affects the probability of having an accident, A few participants wanted specific information which seemed to be missing from the scenario, such as the criteria or cost of the cheapest tier, as well as more examples of similar cases. In scenario 2, process of the decision-making appearing in almost half of the responses. The vast majority of the responses asked about and offered other important factors that the system should consider in this context, such as health condition, reason for their flight, and disability status of the passengers. Some participants argued that the factors mentioned in the prompt were irrelevant to the scenario. A number of responses specifically mentioned age and gender in their responses regarding their appropriateness in this scenario. We were also interested to see whether people who found the factors used in the decision-making process appropriate will also think that the decision-making process is fair. The results show significant differences between the responses of the participants in scenario 1, in their majority reporting that the factors used in the decision-making were appropriate. However, they do not believe that the decision-making process was fair. In scenario 2, we do not have a statistical significant difference between the two scales, where participants in their majority agree that the factors used in the decision-making process were not appropriate and believe that the decision-making process was not fair. Qualitative results show that in scenario 2, participants felt that the use of gender and age as factors to determine the decision were not appropriate, and this explains the results of the quantitative analysis. We also were expecting that people who indicated the decision-making process was not fair will not trust the system's decision more than a human's decision. For both scenario 1 and 2, we did not get any significant differences between the two scales. Specifically, the majority of the participants in both scenarios believed the decision-making process was not fair, and they indicated that they would not trust the system's decision more than a human's decision. Moving now into scenario 3, we have 3 cases. The scenario was about 2 people who were applying for a loan in a bank. The first case was giving the outcome of splitting the money 50-50. The second case was proportional to the payback rate of that person. And the third case was giving the money to a single individual. Next, we wanted to examine whether the different decisions in scenario 3 affected participants' perception of the above constructs. To compare the responses in scenario 3, we followed a within-subject analysis using ANOVA repeated measures, followed by a Bonferroni post-hoc test. There were significant differences for the scales of agreement, appropriateness, fairness, deserved outcome, and trust in responses provided by the participants. The post-hoc tests showed that participants perceived the decision in case B, the proportional outcome, as the most just, while the decision on case C as the least just. Looking into the qualitative responses of the participants, in case A, the majority of the participants asked about specific information missing from the description of the given scenario. Process was the second most common theme in case A, and the most common theme discussed by the participants in case C. Race and gender, again, was the most common theme discussed overall. Since this study, run with undergraduate and postgraduate students in fields adjacent to algorithmic development, it is natural to examine whether the participants' level of education made a difference in their responses. Scenario 1 was the only scenario where statistical significant difference in understanding were found, with postgraduates indicating that they understood the process that the system is following in making a decision better compared to undergraduates. There was no significant difference between the two groups with respect to the other parameters. In scenario 3, case B, which is the proportional case, undergraduates find the information provided less sufficient compared to the postgraduates. Looking if there is a difference in the agreement with the decision for case C, undergraduates agreed less with the decision of the system compared to the postgraduates. Following the same line of thought, we examined whether there is a difference in the perception of appropriateness of the factors considered in the system's decision. In case C, undergraduates considered the factors used in the system for making the decision less appropriate. Finally, undergraduates indicated that the decision-making process was less fair compared to the postgraduates. Similar to previous work, we found that factors are context and output dependent, something that is also obvious in our qualitative analysis. Surprisingly, in the scenarios describing a car insurance premium, scenario 1, and an airline rerouting, scenario 2, participants tended to both agree with the decision and believe that the person in the scenario did not deserve the outcome. Considering that participants often noted that some important factors were missing, this could imply that the participants find that while the calculations with the given information are accurate, the process needs to take into account other factors and therefore that does not actually calculate the most just decision for that person. Participants generally find that some important factors were not considered, highlighting the complexity of real-life situations and the context-dependent nature of the algorithms. Bringing it all together, fairness and justice, when it comes to algorithmic systems, are very difficult to be defined. Several parameters need to be taken into account, and factors are context and output dependent as we have seen from this study. Explanations might not always be the solution to fairness and transparency, and different explanation styles should be considered according to the audience. And this brings us to the individual viewpoints that need to be taken into account when we are developing such systems, due to the diversity that exists among their users, and also the bias that exists in the society and that is brought in these systems. I would like to thank you for your attentions, and my team and I will be waiting on the Q&A session after this talk to take your questions. Thank you very much.